Hello everyone and welcome to CCNA Lab Configure and Modify Standard IPv4 Access List. The objectives for this lab is Part 1, verify connectivity between hosts. Part 2 is configure and verify standard numbered and name ACLs. And Part 3 is modify and standard ACLs. And network security and traffic flow control are very important issues when designing and managing IP networks. The ability to configure proper rules to filter packets based on established security policies is a valuable skill. In this lab, we will set up filtering rules for two business locations that are represented by R1 and R3. Management has established some access policies between the lands located at R1 and R3, which must implement. The edge router sitting between R1 and R2 has been provided by ISP, will not have any ACL. We would not be able to or allowed to any admin access to the edge router because we can only control and manage our own equipment, which are close to us. Okay, according to the instruction, the first step to do that is to test the connectivity. First one is connectivity from PCA to PCC and D. To test that, we can go to ping 192.168.30.3. It's good, as you see, and for PCD, ping 192.168.40.3, and it's acceptable, successful. And from R1, ping PCC and PCD. Ping 192.168.30.3, successful, and also PCD, successful. And from PCC, ping PCA and PCB, ping 192.168.10.3, and also 20.3. And then from R3, we need to ping PCA and also PCB. And let's see if we can ping our server as well from any PC here. Ping 209.165.200.254, accepted and successful. Ping 209.165.200.254 and successful. Now, in part 2, we need to configure and verify standard numbered and named ACLs. The first step is configure a numbered standard ACL. As you know, standard ACL filter traffic based on the source IP address only. A typical best practice for standard ACL is to configure and apply the ACL as close to the destination as possible. For the first access list in this activity, we need to create a standard numbered ACL that allows traffic from all hosts on the 10.0, this network, /24 network, and all hosts from 20.0, /24 network to access all hosts on 30 network, 30.0 network. The security policy also states that an explicit deny any access control entry, or ACE, also referred to as an ACL statement, should be present at the end of all access lists. The question is, what wildcard mask would you use to allow all hosts on 10.0/24 to access the 30.0/24? Because the subnet mask is 255.255.255.0. The wildcard needs to be 0.0.0.255. And following Cisco recommended best practice, on which router would you place the ACL? Basically, we have to put it on R3. On which interface would you place the ACL and in what direction? We have to put it on G000, and ACL should be applied going out, which is outbound. And to do that, we go to R3, conf T, access list 1, remark, allow R1 lands access list 1, permit 192.168.10.0, and then the wildcard 0.0.0.255, and also the same thing for 20.0, and then access list 1, deny any. So we let these two networks go through, and then we deny anything else. Now we created the access list, we need to apply it to the interface. Interface G000 and IP access group 1, because the access list number was 1, and 2 outbound. Let's verify the numbered access list. To use our various show commands, we can use various show commands to find that. In this case, we can use show access list, show access list. As you see, we have access list number 1, and then permit 2 networks, and then deny all. And if you know the number of the access list, you can say show access list 1. And even if we go to the interface, show IP interface G000, you can see that outgoing access list is 1. Now let's test the access list. See if it allows traffic from 192.168.10.0 network to access the 30.0 because we permit them. So if we ping 30.3, good, it can ping. And let's see if 20.0 can ping 32, ping 192.168.30.3, good. PCD to PCC, so from here to here, see if that works. So ping 192.168.30.3, destination host unreachable, and it's not accessible because the ACL that has been configured on this port going out of the router did not allow anything else apart from 10.0 and 20.0/24. On R1, let's see if we can ping 192.168.30.3. Unsuccessful. The ping fails. When you ping from the router, it uses the closest interface to the destination as its source address. The pings had a source address of 10.1.1.1 because of this router, and that the access list on R3 only let 10.0/24 and 20.0/24 to be accessible or to be acceptable. And let's now check the access list here. Again, show access list. You see 4 matches here and 4 matches here. On the next step, let's create and configure a named standard ACL. Create a named standard ACL that conforms to the following policy: allow traffic from all hosts on the 40.0 and to all hosts on the 10.0. Also only allow host PC access to the 10.0. The name of the access list should be called branch office policy. And where do you put that access list? Obviously, you put it on R1, and again, where do you want to put which interface? You put on G000 and again outbound. In R1, let's do that. Conf T IP access list standard, and the name of that should be exactly like that. And now we can permit host 192.168.30.3, and then we can permit a network of 192.168.40.0.0.0.255 as a wildcard, and then end. And the first for the first entry in the setup host, we could say 0000, which is one host only. And now we need to apply that access list to interface G000. So if we go to conf T interface G000 and IP access group, now the exact name of that access list, and then the direction, which is outbound. And we need to verify that access list now. Show access list, and this is our access list name, and then that's these two. Is there any difference between access list on R1 and the access list on R3, and what is it? There is no line 30 obviously here to deny any on R1. It is implied. You may wish to emphasize this to like your workers or whoever is doing that, and tell them there is, and basically deny at the end. But it's very good practice to put that deny all at the end, or deny any. So on R1, again, if you get another show command, show IP interface G000, again, same thing. You can see the access list and name in that. Test the access list from PCC and see if we can ping that. Ping 192.168.10.3 accessible, and test the access list to ensure that only PCC has host is allowed to access 10.0. We can do extended ping as well from R3, for example. If we say ping, then it says protocol IP, just press enter, What is the target? Is 192.168.10.3, and then repeat counts. You can leave it as it is. It's normally by default is 5. Datagram is 100. Leave it. Timeout is 2, and extended command you put yes, and source address of the interface 192.168.30.1. Type of service, just press enter to the rest, and unsuccessful as you see. And test the ACL to see if allow traffic from a 40.0 network to have access to that. So we go to 40.0 and then ping 10.3 accessible. And now we need to modify standard ACL. It is common to business for security policies to change. For this reason, ACLs may need to be modified as well. In this part, we will change one of the ACLs that we configured previously to match a new management policy that is being put in place. Let's attempt to ping the server from PC A. As you see, network is not, or that the host is not accessible, or the ping is not successful. The ACL on R1 is blocking internet traffic from returning to PCA. This is because the source address of the packet when it's coming back is this network, and that's why it doesn't accept it, or doesn't let it to come through. Now management has decided that traffic that is returning from this server should be allowed full access to the 10.0. Management also wants ACLs on all routers to follow consistent rules. A deny any ACL should be placed at the end of the old ACLs, and you must modify the branch office policy ACL. We will add 2 additional lines to this ACL. Option 1 is we can put a no IP access standard branch office policy in global configuration mode. And this would remove the ACLs from the router, depending upon the router iOS. One of the following scenarios would occur. First one is all filtering of packets would be cancelled, and all packets would be allowed through the router, or because we did not remove the IP access group comments on the G01 interface, filtering still is in place. Regardless, when the access list is gone, you should retype the whole ACL or cut and paste it from a text editor that you've done it previously. And option 2 is we can modify ACL in place by adding or deleting a specific line within the ACL. This can be handy, especially when ACLs are too long and we have too many ACL or permit and deny commands. Or retyping the whole ACL or cutting pasting can easily lead to errors. And now in step 1, part 3, let's modify a named standard ACL. In R1, we go show access list. As you see, these permit lines, 2 lines, 10 and 20. We can go to conf t IP access list, standard, branch policy. We can add something line 30, permit 209.165.200.224.00031, and line 40, deny any. And now we can end it. And now we can verify show access list, verify these two lines that we added to that. And now we can, on next one, do you have to apply the branch office to G01 interface on R1 or G00? No, because IP access group, that branch office policy out command is still in place. And let's test the ACL and see if it's working now. As you see, it worked because now we let this to come back in. We have a couple of reflection questions. As you can see, number one is, as you can see, standard ACLs are very powerful and work quite well. Why would you ever have the need of using extended ACL? And the answer is, standard ACLs can only filter based on the source addresses. Also, they are not granular. They allow or deny everything. That means all protocols and services. Extended ACLs, while harder to write, are well suited for complex networks where you may need to allow traffic for only certain layer 4 ports to have access to the network while denying others. In addition, standard ACLs must be applied as close to the destination as possible. This allows unnecessary traffic to use a network boundary. Extended ACLs can block traffic close to the source. This prevents unnecessary traffic from traveling to the destination where it is blocked. In question 2, more typing is typically required when using a named ACL as opposed to a number ACL. Why would you choose named over number? For two reasons. The first reason is that using name ACL gives you the ability to modify a specific line within the ACL itself without retyping the entire list. Note that newer version of the iOS allows numbered ACLs to be modified just like named ACLs as well. Secondly, having a named ACL is a good best practice as it helps to document the purpose of ACL with a descriptive name. Thanks for watching, and we will see you in next lab.